we're going to continue the your turn. We're going to do problem number 2 this time around, which we're just factoring with the GCF. So we're going to look at all 3 terms in the following polynomial, and we're going to find the GCF. If we take a look across numerically, I can see that they all have a 7 in common, and just like in part A, we can do that formally as well if we need to, and then they all have an x in common. And now I'm going to rewrite this as equaling that GCF 7x, and I'm going to get prepared for having a trinomial with a minus and a plus, and 7 will go into 28 4 times, x will go into x cubed, x squared times, 7 will go into 56 8 times, x into x squared, x times, and then we have a 7 going into 70, and that will go 10 times, and x into x, that will go x times. Oops, look what happened. 4, 8, and 10. Those actually have a GCF. So I didn't get the GCF out of those. I wasn't able to see the GCF just by looking at them. So maybe it's not the best idea. So if we go back and we look at problem A here, look what I did. I made us do our work for a problem that followed. That's not something that's rare in my problems. Be aware of that. So we actually have an extra 2 that's still in common here. So 2 times 7x, which gives me 14x, and therefore we have a 2x, because 4 divided by 2 is 2, x squared, minus 8 divided by 2, which is 4x, and then plus 2 goes into 10 5 times. And now we see this. And those were the numbers, remember, that we had before. 14 will go into 28 2 times, 14 into 56 4 times, and 14 into 75 times. So sometimes it's not a very good idea to eyeball things, and I just wanted to make that point. And also the point that when you're doing my problems, a lot of times there will be relationships between one problem and another. All right, now moving on to the next one. There are no variable GCFs in this, and the largest factor that they have in common is 3, and I am positive on this one. So we have a 3 written out here, then preparing for a trinomial, minus and a minus here. 3 goes into 9 3 times, and then there's still the x cubed, y, and then y squared, sorry, and 3 goes into 12 4 times, and an xy here, and 3 goes into 9 3 times. Now, kind of hitting back to that part A here, in the future, we may be able to factor this trinomial further, and so that's something else in the future that we'll want to pay attention to as well. Just because you factored a GCF doesn't mean you're necessarily done. Part B doesn't factor anymore, guaranteed though. All right, looking at part C here, what I'll see is that I have a 15 in common. There's nothing in common between a squared and b squared, so I'm just going to take out the GCF of 15. So this is going to look like 15 times, and then out of the a squared, I'll take 15a squared, I'll be left with an a squared, and out of the 60b squared, I'm going to be left with 4b squared. Now this is another instance that later on, after we learn some more factoring strategies, we could factor further, but with our skills, it's currently as far as we can go. On the next one, we see a GCF that is a binomial, and we're going to take that binomial GCF of a plus 1 out. So we're going to rewrite this as a plus 1, and then get prepared for a binomial, minus in between, taking it out of the first one, left with an a squared, taking it out of the second one, we're left with a b squared. And again, when we learn some more factoring strategies, this one will factor further as well. So I'm going to put little stars by these two and telling us that we could factor them further. And then this first one, we'll want to check that one as well to see later on if we could factor it further. So we'll have some that do and some that don't factor further, but that'll be food for thought later on. So that ends problem 2. The next lecture we'll do problem number 3.